My name is Brian Bickell. I'm the VP of Strategy and Alliances at a company called Cube. And today I'm going to be talking about the need for an open standard for semantic layers. And a little bit about me. I've been here at Cube for about 15 months. Before that, I spent a lot of time in consulting and kind of bouncing all over the data ecosystem. And yeah, really enjoying my time at Cube. And like I said, happy to be here speaking with you. So today I'm going to talk about semantic layers as a category and specifically how we feel the industry can benefit from an open standard. Semantic layers are sometimes called metric layers, so maybe that's what you know them as, but they're a very new category. And when I talk to people about it, generally speaking, most of the data engineering community seems to get the idea behind them, but they kind of are sometimes confused on some of the details. And they may understand exactly like that we need a semantic layer, but they may not quite grasp how it might work at a high level. And if we kind of zoom in and think about the details and how we might implement this, such as like how metrics should be defined and maybe how integrations with BI tools or other data consumption tools work, things get a little fuzzy. So in engineering, quite often we separate interfaces from their implementation. And this talk is an attempt to define and categorize outward interfaces of the semantic layer rather than really drill into implementations. Implementations are, of course, a detail that we're going to leave to each vendor who is building their own semantic layer. And, these ideas are the results of a lot of conversations that we've had with folks in our community, whether that's partners that I look after, in my alliances and my ecosystem program, whether that's different sort of users we've interacted with or stakeholders. And really, this is all just a collection of sort of observations where we're talking about the definition of the semantic layer as a category and what features and capabilities semantic layers should have. So I'm sure that many of you may be unfamiliar with semantic layers, and some of you probably know what they are, but let's go ahead and start with the basics and define the semantic layer itself. A phrase that we commonly use here at Cube is that semantic layers are about applying dry principles to data consumption architecture at scale. If you're not familiar with dry, this idea is don't repeat yourself. It's often sort of advice given to software engineers, and we think about it a lot when we're building systems. But semantic layers are really about building consistency of data modeling between many upstream data sources and many downstream data tools. As the types of downstream data tools have exploded over the years, we found semantic definitions creeping into more and more tools, leading to inconsistency and repeating ourselves, which we just said we don't want to do. So really what we want to do is we want to define metrics once in a semantic layer and then use them many times. From a feature perspective, exactly how a semantic layer helps with this, it seems that we as a community have arrived at four main pillars. First, we have the foundation of everything that a semantic layer does, which is data modeling. And that's where dimensions, measures, and metrics are defined. Some semantic layers choose to do this with a visual interface, but Cube elects to do it in a code-first experience, supporting JavaScript, YAML, and Python. This allows us to adopt software development ideas like version control and multiple branches and being able to do like dev, prod, and other kind of testing paradigms. Next, we have access control, which is important because metrics are frequently filtered by user roles or restricted entirely by access policies. Column level masking or row level security or other common features would be handled here. And this is where you'd be able to do things like multi-tenancy for maybe a embedded analytics or a customer facing use case. Third, we have caching, which is pretty common, and caching provides for fast access to these metrics and prevents us from having to issue repetitive queries to a data warehouse, which can potentially save us some cloud data warehouse spend. It's also quite important for a feature when we come to serving things like user-facing analytics or customer-facing dashboards or embedded dashboards, because again, you get judged on a much stricter time criteria in those domains than maybe you do in like traditional business intelligence. And finally, APIs are how we deliver all these metrics to all of the data applications we're supporting, whether that is a SQL API for business intelligence tools or something like GraphQL for embedded analytics for data applications, or more recently things like AI-enabled systems. From the whole data stack perspective, Let's take a look at that. We believe that a semantic layer sits between one or more data warehouses typically and many data consumption and visualization tools, and that's sort of the crux of the problem we're trying to solve. Data in the warehouse is usually transformed with tools like dbt or SQL Mesh into normalized tables that represent business entities. These business entities are then consumed by the semantic layer. A semantic layer will act as a denormalization engine in this case, which creates metrics, smarts, and then exposes them to downstream data consumption tools and visualization tools. So that being said, why do we actually need a standard? Well, really, for semantic layer to be valuable, the promise is that we have to bring consistency to all of the downstream tools. And this means that they really all need to work very well with the semantic layer and integrate deeply, and really need to ensure a first-class user experience. This is an important matter for adoption because specifically if you're a user of a tool like Tableau or Power BI and you are connecting through a semantic layer rather than like directly to a cloud data warehouse, if a certain set of feature functionality doesn't work, that's going to be a problem for you, and it's going to be a detriment to adoption, within a department or within an organization, and really for the category as a whole. Where the challenge is is that for developers of semantic layers, we have an ever expanding set of technologies that customers expect us to integrate with. So when thinking about this problem, we think there's something that we can adopt from other areas of technology with competing implementations. And this idea is the idea of standardization. So let's zoom in on a single BI tool and maybe think about how this might work. How would maybe in this case Tableau connect to a semantic layer that is outside of itself? If we're the semantic layer developers, we can build one-to-one connectors, and we could put a lot of time and a lot of energy in working on specifically a Tableau connector, for example. But the problem is that BI as a market is very fragmented and kind of becoming, even more fragmented every day. There are a lot of visualization tools and business intelligence tools, and really this idea is like why we think we need a semantic layer to begin with is to try to manage this chaos and provide a single source of truth and central definitions in one place that is not in the BI tool. The problem with this then is how can we bring an experience of an integrated semantic layer to this decoupled architecture that we're talking about? Let's go ahead and talk a little bit more and define maybe the integrated semantic layer and the decoupled architecture. So if you know Looker, and many of you here probably do, Looker is a really great example of a well-built BI tool with an integrated semantic layer. In fact, we would say this semantic layer, LookML, was probably key to the overall success of Looker. When you work with LookML, which is a code-first semantic layer, you define different objects that are called explorers. And then those explorers that are defined, you can actually just see them in a drop down in the UI. They're very well integrated. It's easy to use. And this is what we mean by a fully integrated semantic layer. Many BI tools have integrated lightweight semantic layers. We just talked about Tableau earlier. They have a concept of a Tableau data source. In Looker, this is LookML. Tools like ThoughtSpot have quite sophisticated ontologies and synonyms that they require. So each individual BI tool typically implements its own lightweight semantic layer of some kind. However, a decoupled semantic layer is when the semantic modeling portion is an independent tool from the downstream application. There are a lot of benefits of this because we can define metrics once and then reuse them across all visualization tools, of course. But the challenge is, as an industry, how do we make sure that BI and visualization tools reflect what we have defined in our standalone semantic layer? When a data team defines a metric in the semantic layer, we want data consumers and the BI tools to see this metric in the UI, and we want all of the corresponding dimensions and filters and different capabilities to work correctly. Because these systems are decoupled and often being developed by different vendors, we really need some kind of standard to make sure that we can make this integration possible. And at Cube, we argue that the standard will help to align visualization tools and semantic layers to achieve a user experience that is actually similar to these integrated semantic layers. Especially at scale, when one semantic layer needs to support multiple data consumption tools, and data consumption tools conversely need to know how to support multiple semantic layers, we believe that standardization will be key to making interoperability possible and improving outcomes for folks in the ecosystem who have to build connectors for all this stuff, and also for buyers who may want to implement a semantic layer but may be concerned about the potential for vendor lock-in or really committing too hard to like one ecosystem and want some kind of escape hatch. So let's talk about what this standard should cover. So far, we've talked about the need for a standard and why, but let's actually get to brass tacks about what a standard should cover. And again, we're going to talk about the interface first, which that's specifically the outward representation of the semantic layer. Remember, this talk, we're not really focused on implementation, rather just the interface between tools. So when we think about this, we think this looks like the specification of objects to describe a semantic layer. We talk a lot about metrics in thinking about semantic layers, and metrics are aggregated expressions on top of columns. But we also have non-aggregated values on top of entities, and we need to have a way to accommodate those as well. We consider querying protocols, which is how exactly a BI tool or a visualization tool will query the semantic layer. How are we going to access that? What are the protocols we're going to use? And finally, we think about a metadata API, which is really about the synchronization of semantic layer objects with native objects inside of BI tools. So let's cover the objects that we use to describe a semantic layer, about the interface and how these objects are exposed to data consumption tools. So far, what we've seen from the industry, there are mainly two approaches to this, which I'm going to classify as what we call metrics first and what we call dataset first. And let's go ahead and dive into the metrics first case. When we're looking at metrics first as an approach, metric is the first class object that usually has a time dimension and some number of related dimensions that go along with it. And in this case, the semantic layer is exposed as a list of metrics, and data consumers will use that list as an entry point when they're working with their analysis. As an example, if I wanted to look at average order value as a metric, first, I might load up my tool and I would go to a list of metrics, search for it, and then start my analysis there. Once I have the metric and I'm kind of looking at it in aggregate, I would most likely bring the metric and cut it maybe with a time dimension, aggregated at a month or a quarterly, and then maybe bring in some other dimensions to better understand a breakdown, such as state or country, or anything else that I've provided for in my dimensions. Now, let's look at maybe some of the cons and the pros and the cons of this design. The upside is that this design is close to how everybody thinks about data. When we talk about metrics, we understand what that means. You're probably gold on some metrics within your business. Maybe you set them as OKRs even, or some other management framework. It's really quite easy to communicate about the idea of metrics to people within an organization. But the downside is that most data tools yet don't really have an idea of metrics, and they don't really know what to do with metrics. The long history of BI tools and analytics tools are quite table-based in nature. A lot of them support tables. Perhaps they support multi-dimensional cubes, but they're not exactly metric-based yet. And that creates a lot of challenges when integrating with a wide ecosystem of tools, which again goes back to my point about adoption and kind of how that we really make sure that semantic layers can provide the most value. It's also unclear in this scenario with metrics first how we would handle non-aggregated values. We don't really know how they'll fit into a model. I mean, what if we just want to see just an order value for a specific order, not an average order value, which is an aggregation? If we only expose metrics at the top level in our UI, it's unclear exactly where order value should even go. How do we handle like a single value on an entity and on one entity, like at a row level? So let's look at maybe the alternative here, which would be what we call a dataset first approach. The dataset first or dataset centric approach is essentially tabular based, and it's a table that describes an entity. Columns in this table could be measures, they could be metrics, they could be dimensions, including a time dimension, like distinct entities. In this case, the semantic layer would be exposed as a list of data sets, and data consumers will use that list as an entry point. If you want to look for average order value in this model, you would go to your list of data sets, search for orders, and then pick the average order value measure with a time dimension or with any other dimension that you need for your analysis. Um, this is the model that we have implemented at Cube and the way that Cube works as a product. And we believe this view of the world sort of has more pros than cons. But first, let's talk about the problems. The downside is that this is a harder abstraction to comprehend. First, we're dealing with data sets and tables, but because they have measures, they're actually multidimensional in nature, which makes them harder for users to understand compared to metrics. It's also harder to always fit metrics into entities. Some cases, this is quite clear, like in an order and an average order value case. But what if we're talking about revenue? It's unclear exactly which entity that belongs to. We may have to make some suboptimal choices here. However, the upside is that BI and visualization tools support tabular data in multidimensional cubes with measures and dimensions. That's just how most of them are built. And we get compatibility with the long tail of BI tools quite easily here. As I said, this is a model that can easily fit into BI infrastructure, and that's a strong point in favor of adoption. There's also an opportunity to use the best of both worlds with this approach and combine the data set centric view of the world with metrics. Would argue that metrics can be a special case of the data set centric approach where we deal with a single table where only one column is a measure and the rest of the columns are dimensions. In that way, we're sort of putting the metric into a box, the table as a box, and then using that as a container to transport across multiple BI tools. In this way, we can combine entity modeling, which is well understood, with metric modeling within a single project, maybe for different personas or different use cases. The entry point in this use case would be a list of tables, but using a proper naming convention, we can separate entities from metrics and use them together in the same project. So far, when working with different partners of Cube, we've received positive feedback from our implementation design partners and in working with this model. So next, let's talk about querying protocols. The semantic layer, as a concept, really should be able to provide a fully fledged querying interface to deliver metrics to all of the possible data consumption tools out there. Currently, most data tools use a SQL protocol to query data from databases and data warehouses. If we consider that, then the semantic layer solution should expose SQL as an endpoint, so all existing tools can connect to it and query metrics. Additionally, we would say for future-proofing use cases, it's really important that semantic layers provide an HTTP-based interface for customer-facing app development, embedded analytics, AI-enabled use cases, and kind of future state. As an industry, we've seen a lot of adoption of GraphQL as an open source data query manipulation language, and it makes sense for semantic layers to support that as an API. This actually leaves us next with MDX to consider. MDX is quite well adopted inside the Microsoft ecosystem, but not so much outside of it. Within the Microsoft ecosystem itself, again, MDX is everywhere, but it's a huge ecosystem, and it's something that really, even if it's just Microsoft tools, it's hard for us to ignore that. The Microsoft ecosystem is so large, we ignore it at our own peril. But it's kind of an open question in the field of whether the Microsoft ecosystem will become more SQL friendly or whether semantic layers should go that direction and support MDX as maybe a third or a fourth API. So let's look a little bit more at the SQL case. There are multiple ways that a semantic layer can use SQL as a transport. One of them is what we call a big scale extension to SQL. That's where we really just use SQL as a wrapper and transport layer, and we use our own language embedded within SQL. That kind of allows us to design our own language however we want and make it very native to querying metrics. But the downside is that it's going to be a lot harder for BI and visualization tools at scale to use this because BI tools, of course, they generate SQL and they're very dependent on ANSI SQL standards. And when they query their data sources, they don't know they don't know yet, really, at least, like how to generate that custom language that we come up with. So that's going to be a much harder struggle for implementing support for things like Tableau, for Power BI, for maybe what we would call more legacy BI tools. The other way to kind of wrestle with this is what we call like a small scale extension to SQL. If we consider data set or combined approaches where we expose tables as top level objects, SQL can already work with this because it works with tables just fine. The tricky part is that SQL doesn't exactly have an idea of a measure. And when I say a measure, what we mean is that a measure should be a special type that knows how to evaluate itself. In our example, we've been talking about querying average order value, for example. In SQL, we don't really need to specify that expression because we've already defined the expression in the semantic layer, but we need to be able to refer to it as a special type which knows how to evaluate itself. And that is whether it's a simple expression or it's a derived expression or something with complicated predicates or a ratio. We would propose that this could be done potentially by extending SQL with a measure type and with a special function, a special aggregate function, I should say, to query measures. Last piece, but not the least important, is the metadata layer that we talked about in the beginning. As a decoupled semantic layer, we really need to be able to inform downstream tools about our capabilities. We need to let them know what our data models look like, what of course, the dimensions, measures, metrics are. And in the case of a BI tool like Tableau or Looker or something with a lightweight semantic layer, we also need the ability to synchronize metadata between those tools, from our semantic layer to whatever they call their lightweight semantic layer, whether that's a Tableau data source or like LookML or something else. And we need to do this to ensure kind of user interface compatibility, continuity, feature functionality. And here there's sort of an open question of whether or not this should be implemented as a push or a pull functionality, or if there's some kind of standard that we can define for our meta endpoints to build a common interface. This is also becoming more relevant as a problem, with recent advances in like AI-enabled tools, and specifically around analytics tools that are needing to potentially pull an entire state of a semantic layer and feed that into an LLM, whether that's through a vector database or through some other kind of way of providing context to the LLM or to constrain its output in some way. So yeah, there's some ideas here about whether or not this should be a common metadata manifest format, but there's still a lot of, I would say, area to think about in metadata and how we can standardize that.